this is the question paper or MCQ section from thermodynamics. Okay, so in these topics, that is thermodynamics, I have completed 2 lecture, and if आप लोगों ने वो 2 वीडियो अगर नहीं देखा है तो आगे जाकर पहले वो 2 वीडियो देख लेना, फिर MCQ सेशन कर लेना, क्योंकि वो 2 वीडियो बहुत ही हेल्पफुल रहेगा आपके लिए. ओके, सो ये बेसिकली ये जो MCQ सेक्शन है वो बहुत ही इम्पोर्टेंट है फॉर एग्ज़ाम पॉइंट ऑफ व्यू से, झारखंड SSC PGT के लिए भी और वेस्ट बंगाल मद्रासा PGT केमिस्ट्री के लिए. ओके, सो द फर्स्ट क्वेश्चन इज ए गैस इज compressed from 20 liter to 8 liter at 2 atmosphere pressure, then work find work done. Okay, so we know that the formula of work done is equal to minus P external into delta V. Okay, so here the volume, initial volume and final volume are given. So delta V is equal to V final minus V initial. Okay, so that is 8 minus 20, that is minus 12. Okay, minus 12. So I have put this value minus 12, and P external here given, that is 2 atmosphere. So minus 2 into 12 minus 12 is equal to 24 liter atmosphere. Okay, the unit is this, this is liter atmosphere. Okay, but you have to convert this into joule. So I know that 1 liter atmosphere is equal to 101.3 joule. Okay, so 24 into 101.3 joule. Okay, so this is the answer. Next, in an isothermal process, volume of a gas is increased from 1 liter to 2 liter. If heat absorbed by the gas is 500 joule, then find change in internal energy in calorie. Okay, so here the value is given R, for R is equal to 2 calorie per mole per Kelvin. Okay, so we know that for isothermal process, temperature is equal to constant. Okay, and V1 is equal to 1 liter and V2 is equal to 2 liter, that are given. So delta V is equal to 2 minus 1, that is 1 liter. Okay, here Q is equal to given, that is 500 joule. Okay, so here delta E is equal to 0. Internal energy change is equal to 0 for isothermal process. Okay, and I will I have completed in this video the lecture 1. Okay, this concept is given there. Okay, next, in a closed insulated container, a liquid is stirred with paddle to increase its energy by 500 joule, then which is correct? Okay, if Q is equal to 0, why? Because this is closed vessel. Okay, so no heat change is required, so Q is equal to 0. And from first law of thermodynamics, we know that internal energy is equal to Q plus W. So internal energy is equal to W. As Q is equal to 0, so delta E is equal to W not is equal to 0. So option B is equal, B is here correct option. Okay, next, if heat absorbed by system is 400 joule, then find delta E. If first case is if work done on the system is 100 joule, next case is if work done by the system is 100 joule. Okay, so you know that if system is worked, that is work done by the system, then the sign is negative. Okay, and work done on the system, that is surrounding work, then it is positive. Okay, so first case, that is W is equal to 100 joule, because surrounding here works. Okay, and work done on the system. Okay, so W is equal to 100 joule and Q is equal to 400 joule, that is given here. So from the first law of thermodynamics, delta E is equal to W plus Q. So 400 plus 500 is equal to 400 plus 100, that is 500 joule. Next case, if work done by the system is 100 joule, that is work done is equal to negative side. Okay, so minus 100 joule, that is delta E is equal to 400 minus 100, that is 300 joule. Okay, next, for the reaction, that is C3H8 gas plus 5O2 gas equal to 3CO2 plus 4H2. Okay, So at constant 27 degree centigrade, delta H minus delta I, what is the value? These are the options. uh, so we know that delta Ng, that is change of moles, is equal to, we know that number of moles of product minus number of moles of reactant. Okay, summation, that is here in this case product is equal to 3 moles, and here that is 5 plus 1, okay, 6. So 3 minus 6 is equal to minus 3. Okay, and we know the formula is equal to delta H minus delta E is equal to delta Ng RT. Okay, so if we put the value delta Ng, then minus 3 RT is the correct answer, and option C is the correct. Okay, next, what is the difference between heat of reaction at constant pressure and constant volume for the reaction? We know that heat at constant pressure, that is called delta H. Okay, and heat at constant volume, it is called delta E. Okay, so heat at constant pressure is equal to enthalpy, and heat at constant volume is equal to internal energy. Okay, so the difference, that is here asks that delta H minus delta E is equal to what? So for this reaction, 2 C6H5 C6H6 liquid plus 15O2, that is gaseous, is equal to 12 CO2 gaseous plus 6 H2O liquid. Okay, so if we calculate delta Ng, that is summation over number of moles of reactant, product minus summation over number of moles of reactant, that is equal to 12 minus 15. Okay, only gaseous molecules are included here. Okay, so minus 3 is equal to delta Ng is equal to minus 3. Okay, so delta H minus delta E is equal to delta Ng RT, that is minus 3 into here I will put the value the R. Okay, so 8.314 joule per mole per Kelvin, and temperature here 27 degree centigrade, 25 degree centigrade, that is 300 Kelvin. Okay, so if we calculate this value, this is 7470 joule. Okay, but here the question asked that is in kg joule, so 7.470 kg joule. So here correct option is option C. Next question, for a sample of ideal gas, when its pressure is changed isothermally from Pi to P initial to P final, the entropy change is given by. Okay, so this is the formula from the direct isothermal process, that is entropy change. Okay, so I have completed this part also in the first class, I think. For the isothermal process, temperature constant. Okay, so here delta S is equal to nR ln V final minus V final by V initial. Okay, and from the ideal gas law, we know from Boyle's law, you know that pressure is inversely proportional to 1 by volume. Okay, so if you exchange this volume and pressure, then delta S is equal to nR ln P initial by P final. Okay, so here correct option is option C. Next, for a liquid, heat of vaporization is 30 kJ per mole. If change in entropy is 75 joule per mole per Kelvin, then find boiling point of that liquid. Okay, this is very important question, and this is the formula of entropy, that is entropy change is equal to delta H vaporization by temperature. Okay, here ask that boiling point, so in temperature you can write delta H vapor by boiling point. Okay, so boiling point is equal to delta H vapor by delta S, and you can put the value 30 into 1000 joule per mole, okay, and 7 by 75. So here the correct option is 400 Kelvin. Okay, so the boiling point of the liquid is equal to 400 Kelvin.